Alright folks, hope everybody's enjoying their Sunday afternoon. Just wanted to record a video for what we're going to be talking about tomorrow in class. So let's get started. So these are hypothesis testing problems, and I'm going to do this first problem here. And I'm going to tell you exactly how you should set this up, and you should do it exactly the way I'm doing it. So we have this avid reader who claims that he reads more than 375 pages per book, and we've given some data on the 13 books, and the question is, does the data support his claim? Well, here we go. So here's the information so far. So step one is called name the test. You won't actually need to write this. You need to write this part. So the first thing you got to tell them is I'm doing a t-test because I do not know the standard deviation. I'd write this out, by the way, of the population. This is a one sample t-test. There's only one sample, the 13 books. I'm going to define my parameter. Mu page is the average number of pages per book. Then we have our null hypothesis, which is that mu page equals 375, and our alternative hypothesis that mu page is greater than 375. So that's step one. Is you got to name the test, and you got to tell them the test, one sample or two sample, define the parameter, and then create the hypotheses. Okay. Number two is you have to tell them that the conditions are met. So I'll call this step conditions. There are certain conditions that we have to meet. Conditions. The first one is that there's random sampling. So in this problem, do they tell me there's been random sampling? Let's take a look. A random sample. So random sampling, they told me they pick a random sample of 13 books. All right. So yeah, because it's a random sample, books are picked independently. So independently is the second one. This is more when there's a two sample, like that the two samples are independent, but you can add it in here. So there's random sampling, the books are picked independently. And the third thing is you need to talk about whether this is a normal, like normal distribution. The thing is, we've only picked 13 books. 13 is unfortunately not a large number. So we need to do one thing here. We need to say that with sample size 13, using the central limit theorem, I assume the sample is approximately normally distributed. So these are the three conditions. One, that there's been random sampling. Two, that there is independence. This is more for a two-sample test, so like that the two samples are independent. And three, that the sample is normally distributed. You're almost always going to use the central limit theorem here. All right, so that's step two. Step three is we need to do the math. So we'll call step three the math step. So the math step is the following. Well, we need to calculate the t-statistic. So t-stat, let's take a look at our problem. Here they've given us data. They've given us a lot of data here, so that means we need to use the calculator with the data tool. So the t-stat, but at least write the formula down, is x bar minus mu over standard deviation. Right? Remember, this is, you get this straight from your formula chart. I went over that on class on Friday. So this is really x bar minus mu over s divided by square root of n. So t-stat equals the mu, let's call it mu naught, or this mu little subscript of 0, right? So really the mu of subscript 0 right here. This, in our case, is the same thing as whatever the null was equal to, so this is a 375. So x bar minus 375 over s divided by square root of sample size was 13. Tell the reader that you're getting this and this from the calculator. So let's go do that. So how do I do that? Well, in class, remember, we were always given the statistics, so how do we do that? We come into here, if you're on the 8384, you go to Stat, you go to Edit, clear out all the data, and in L1, just go ahead and put the data in. So type in the numbers that they give us, which are what? 595, 353, 434, 382, 420, 225, 408, 422, 315, 502, 384, 420. So all the data is in here. Then we go to, by the way, these directions are all right here. Now I'm doing one sample test with the data given. Remember, this is data that actually told us the points. So I'm doing these two, by the way. So right now I'm doing this one. So then you click Stat, Test, T-Test. Stat, Test, T-Test. This time it's data. That initial from the H0 was 375. Listed L1, frequency is 1 here, and the alternative is that we are greater than H0. Click Calculate. X bar is 405, and the S is 91. So I would rewrite this as T-stat equals 405, that's X bar, minus 375, sorry, this closed it out, divided by 91 over square root 13, and that equals, here's the T statistic right here, 1.1409. Alright, how do we do this on the Inspire? It's pretty similar. I'm going to be following these directions right here. So we create a new document. No, I don't want to save the old one. Let me go ahead and zoom in a little bit. Add lists and spreadsheets. We need to enter the data into column A. I'll call it X always. So we need to go ahead and put the data in on the number of pages, which is 595, 353, 434, 382, 420, 225, 408, 422, 315, 502, 384, 420. I think I may have missed one because there should be 13 entries here. 595, 353, 434, 382, 420, 225, 408, 422, 315, 502, 384, 420. I think I'm definitely missing one here. 384, 503 was missed. Oops, 503. It's going to throw the data off a little bit. Go back and change the other one. 503. Then it says menus, statistics, stat test, t-test. We're using data. You guys can't see this. So we go menu. So we came menu, statistics, stat test, t-test. We use data. The H0 was 375. The list is in A. Frequency is 1. The alternative is that we're greater. Click OK. Here we go. So t-value is 1.48. This are a little bit different, the X bar and the S from before, because I typed it in wrong. But key point is the t-value is 1.481. So let me change that. 1.4816. This was 412. And again, this only happened because I mistyped the previous one, nothing major. Just a little typing error, it happens. Alright. Calculate the t-statistic. Now, the next thing, let me zoom out. So once you calculate the t-statistic, you need to identify the p-value. The p-value is equal to 0.08. So difficult to see here. 0.0821. So we got the p-value. The significance level is what? Let's go back to the problem and see what they told us. No significance level given, so we assume it's 0.05. Let's draw our picture. This is 0. Here's our t-statistic, 1.48, 1. And we want to know our null hypothesis was greater, so we're in this region right here. This is 0.0821. And now we have the conclusion. Number 4. The conclusion is the following. Since the p-value of 0.0821 is greater than 0.05, we fail to reject. Remember, this was just the other way of saying except. We fail to reject H0, the null hypothesis, and we conclude that the mean or the average number of, we're concluding H0. Here's H0, that it equals 375, and we conclude that the average number of pages equals 375. And that is it, folks. So again, I'm going to pause this video very soon, but let me just review the steps. So step 1 is we need to name the test. We go with a t-test, 1 sample, define the parameters, the hypotheses. Step 2, the conditions, random sampling, independence, and normally distributed. Step 3 is you do the math. You calculate the t-statistic. You get the p-value. Significance level is given. We draw the picture, and then we say because the p-value is bigger than the significance level, we fail to reject. Remember, statisticians prefer this than the word except. Fail to reject the null hypothesis, and we conclude that the average number of pages, we conclude that this is true, the average number of pages equals 375. Let me go ahead and stop this. I'll make the other one.